Hello everyone, Houdini 20 is here and I thought why not make a neon sign of Karma XPU and check out the updates and improvements. And also I am still quite new to Solaris USD workflow and this was a good little challenge for me. But if you see that I am doing something wrong, feel free to write your suggestions in the comment section. In this project, I didn't use any image textures, so shaders are made using procedural noises and some math, just to see if everything is working as expected. First part of this video will be about making the neon geometry. So if you are interested only in Karma part, just skip straight to that. Although I have to say that preparing the geometry correctly for importing it into Solaris is also important. All right, let's start. Let's make a new geometry. Let's call it Neon Karma XPU. I had prepared splines in 19.5 and exported them as an Alembic file because AE lib SVG importer doesn't work in Houdini 20, so I will import that Alembic file. So here it is. We have to check that it's loaded as unpacked geometry, and it also has this path attribute that we don't need. So I will just check that. Let's place this in the center and scale it down to 2 meters wide. Now split it apart. We actually have these parameters here, color and name, and I will use the name to make groups. So groups from name. Now we should have shape and text. Now I can blast away what we don't need and have only the shape. Here we will have the backplate, and the third will be only the text. Now let's see what is happening with the geometry here. Every curve has many primitives. We need clean geometry, so I will use polypath, and this did not help because we need to also fuse some points. And let's check if we need to do it with the other parts. Yeah, we also should polypath that one. Let's just place this here. Okay, so let's place down already the neon generator. Let's see what is happening here. In this case, I actually didn't connect them and used only the cables for connections. You actually can go here in the main tab, don't connect. Previously, I used 20 millimeter diameter. I think we still will have to sort these curves because the cables, if we enable them, yeah, this is not connected correctly. Let's color the cables red for the time being, just to see what's happening. I'll place down the sort by selection and just sort these primitives in more logical order. So now they are sorted, and I will also place the sequential join, and we have this auto direction enabled now. Yeah, should be all right. So let's go to the neon generator again and see what is happening with cables now. Yes, I think this makes more sense, but of course there are some overlaps because there are just too many supports at the moment also. So let's go to the supports tab and see. Yes, now we have these splits, and every split means that there will be a support. So we need to increase a little bit of this angle threshold. Every curve is basically like one line. This makes more sense, I think. Maybe the distance between supports can be increased a little bit so that we have less. We can also change these rotations a little bit. So let's go to the neon tubes end rotations and refresh rotation arms. And let's rotate this maybe actually inwards. Yeah, this line is just very short. We'll probably have to edit it a little bit, but let's find which control is that. Okay, so this one, let's rotate it around like that. Okay, let's rotate them both to inside so that no one sees them. Maybe rotate this one a little bit. I think this could be rotated like that. Let's add some randomness, enable random rotation. We have a little bit of offset, but not too much, maybe like 3 degrees. I will actually edit this short line, select some points, and we get support in the middle there. So that's good. And maybe we should edit this one point also. Adjust this one rotation parameter. Now let's increase the distance from the surface distance, so that the neon does not touch the wall. And also we will use a backplate there. So this is our backplate, and it's actually now an open curve because we used the polypath. Close it down, and let's place a null here. Backplate. And now let's input this backplate into neon generator here in the main tab, backplate, and enable it. But in this case, I wanted the neon to stand on it, and so that backplate goes away from the neon. To do it, I could actually just change this setting, so the depth to the other side, like that. But there's one problem. This neon goes forwards, but backplate goes backwards. And I want everything to stay on the 0. The best way, I think, is to just put down the transform and take this parameter, depth, copy parameter, and put it here in the Z based relative reference. It's basically an inverse transform. Now, when I change this depth, it always stays on the 0. The supports now are going into the backplate. They need to snap to mesh. And because we already have this backplate set up, it's also the default parameter here. So it already uses that backplate. They now stand on it. Now we need to increase a little bit surface distance, and maybe the backplate is too thick now, something like that. We actually don't need the connectors, and I want to change geometry for support clamps to the double wire, and also the shafts, enable the ridges and bevel. So let's make text now. I will just copy the neon generator. Also, I want to split these words in two because it makes it easier for me to deal with the connections and cables. I don't want to have a cable from here to here or something like that. So I will just make a group. So let's call it XPU by bounding regions. And now let's split it. We already see that the sorting is not great. So let's put down the sort by selection again. Just select them in the order we want. But yeah, this looks much better already. But also we want, in this case, to connect the cubes together. Let's say connect all. Yes, A letters are not great, so we need to change the directions of these. So let's place the sequential join. This looks good because we have auto direction on. Otherwise, it looks like this, and this is what we got before in the neon generator, but we want to enable this, and I think this needs to be reversed. Okay, and we want to output original sorted, and we have these end rotation parameters now. Yes, because we copied this node. So let's clear them, refresh, and we have only 2. And yeah, it doesn't work now because sometimes it does that. We need to change some of these parameters. Now they work again. And we also don't have supports because they are set up to be snapped to the backplate mesh. The backplate is here, and here is emptiness. In this case, we will use wall geometry, which also does not exist at the moment. I will add a grid and just rotate it 90 degrees, make it a little bit small. I will use this grid also as a wall in the final render, so we will still need it. And let's put down a null. This is out wall. Let's input this in wall sub. We have back our supports. And let's see what happens here with the support, no, neon tube end rotations. So I think here we want to have this support because it's more realistic that way, or maybe the other way around. Yeah, like that. And now let's do the same thing with the XPU part. We just need to check that we have ordered things correctly. So actually need to reconnect that. Right, let's see what we have here. Now I need to reset this. Don't we see the thing? Right, it needed to refresh the viewport. If we have auto direction enabled again, it actually finds the closest points where it needs to connect to. Let's go to the support placement, the distance a little bit less, so that we have this center support here. We can increase a little bit the snapping threshold here, so that if this segment is shorter than this parameter, these supports are snapped into one. Now let's rotate a little bit those ends again. That looks better. Basically, we have done it. One thing I remembered is that we need to actually add thickness to the glass. So let's just select all of them, go to neon tube settings and enable glass thickness. Let's merge everything together and see what we have. I think in my first version, I used a little bit smaller radius for the neons. So the corner radius was like 1, but I don't know, maybe in this case we can actually leave it at 2 as a default. Okay, I will actually add not the null, but an actual output, because sometimes I enable some other node. Neon generator has all these different outputs. So this first one has everything, packed primitives and meshes and everything together. Here we have mesh, here we have only packed, and then there are curves, and then there are guides. Because we are rendering in Karma, we actually need to think how we will split these things, and to do some adjustments with these geometries. So I will actually not merge the first output, but the second one, because it has only the meshes, and I will also merge separately the packed primitives, and then merge these together. Doesn't make sense now, but it will in the moment, like that. Maybe just for visual clarity, we can set some colors. So let's go to the caps and maybe set darker color for them, and also maybe the supports geometry legs. I think it would be nice to have a little bit different color, something like that. And we have also the wire color, make it the same as our legs. Let's color also the backplate, the color here on the output, put an asterisk here. And I will now make also the other objects, the wall, and I will just merge in this grid we made, object merge, like that. And also I will just make a new grid, which will be the ground. Maybe it adds some reflection, and we can offset everything higher up. So this is our ready-made neon sign. And now let's switch to the Solaris LookDev layout. And I like to have a dark background, so let's change to dark and put down a scene import. Select the neon, except here it is. So we want to split things apart so we know what's where. So we can in this destination path write, for example, geo. So everything will be put in there. So we build our own hierarchy here. I will split the objects basically so that I can change parameters on these scene import nodes and affect these separately if I need to. So this will be our wall, okay, and this will be our ground. Let's merge them together, and yes, here we have our geometry. But of course, there are some issues now. For the neon object, we have all these instances, and only one mesh doesn't have any information about how to split this object apart. We could use here in the settings, import data, we could use these subset groups. So if we put an asterisk there, does it work? Yeah, so we now have these separate subsets, which we could apply different materials to. But I would still actually prefer to have them as separate meshes, because that enables us to hide them or make them invisible, and yeah, there is just much more that we can do with them. So we will not use the subset groups, but we will actually split the meshes apart. And to do it, we actually need name attribute for these objects. Let's go back to the build view, and yeah, I don't know why this does not change like automatically. We change the viewport. This is a little bit frustrating. So let's go here, and Neon Generator gives us a lot of groups, and we can convert these groups to name attribute just by placing down name from groups. And let's delete this here. Let's see, we don't have nothing. Okay, so we need to put an asterisk here. Now we have all the names for all our objects. One thing that I have to specify separately, I know that because I already did this once. I don't have the neon backside name attribute now, probably because it's like overridden by one of these, like this neon outside. To have the name attribute for it, I have to specify it here, neon backside, and I want to have the name neon outside back. So I changed this name a little bit just to be more consistent, because in Karma this is really important that you can select separate geometries in one go. Okay, let's actually check if we have a neon backside here, neon outside. Okay, yes, we have neon outside back. Let's just change it here to the stage. And yes, we have our meshes neatly named, just as our groups were, and they are separate. Let's also change the setting for backed primitives. We can change this from the native instances to point instancer. And as you can see, this is making everything a lot neater. And in this case, we don't have actually too many instances, but point instancer is still better optimized from what I understand. But why do we have so many of these? Because we know that actually we only have four geometries that we use as instances. We use the wire, the clamp, the leg, what else? And then there is, and the caps. So there should be only 4 here, right? And that is actually because if we go back to the SOPs, we have 3 Neon Generator nodes here, and every node inside has these geometries, these caps and clamps and so on. And when we merge them together, they are interpreted as separate, different geometries. It doesn't understand that those are actually the same. They are visually the same, but they could be completely different. So we need to do something about it. And actually, there is a super easy way. We can add back inject. And here we have target primitives and source primitives. So we want to replace back primitives that come in here from these 2 nodes with back primitives that come in from this node. And we need this injection method. We can say collate backed sources, and it needs the name attribute again. But we give the name attribute to everything only here at the end. So we can copy this and place it here and actually merge together only these 2 and place a name attribute here. So we name them, then we say that we take the source from here and target these primitives. Oh, and actually here we don't need anymore that neon group. So yeah, this is what we need. Now if we select this node, everything works, and visually nothing changed. Basically have the same thing, right? But it makes a difference for rendering. Now we need to only merge again together this first part with the second part, like that. Now connect this to there, and this should correct everything. So let's go back to the stage and check. Yes, now we have only the cap, support clamp, support clamp wire, and support leg. That's great. So let's add this new skylight, physical sky. Actually, I want to name these. So this will be our neon. This is our wall, and this is our ground. Let's see what do we have when we enable Karma XPU? Everything is very dark because the sun is on the other side. Right, fans are kicking in, make it brighter. So it seems that the geometry looks good. Everything is imported. Yeah. Oops. All right, for the shading, I actually don't need sunlight, and but I want to have it a little bit brighter, and I can increase the turbidity parameter just to have a little bit less of the blue tint. And let's add material library. I don't know why it makes this one at the end if I don't have any material library yet, but all right. So the library, now add Karma material builder, and I am using this Karma material builder because there is more features inside it. We would use only this USD material X builder, then some of the features that Karma has would not be included in here, and they would not be available in the menus. This is probably if you want to export, and you know that you will want to export some USD files and use only the Material X nodes, then you should use this. But if you know that you will render in Karma, then just use the Karma material. Also, I have a question. Why do we have this inputs subnet node if it does not do anything? I don't know. I have searched and no one can answer. I have only seen people deleting it all the time. So why is it there? I don't know. Let's call this material wall. Then this one will be ground. Then we will have neon. Then backplate. Then material for cables and caps. I will just call that some kind of rubber, and then brass. Oh, actually, no. For brass, we will use one of the materials from this new material catalog, which is in Material Linker. Oh, we also have glass for the supports. Now let's add some different colors to these. So backplate will be some kind of orange again. The rubber will be something very dark. Let's make wall a little bit grayish at the moment, and the ground, leave it actually as white. And neon will be transmissive, but let's leave it at like 0.98, like that. And the specularity with roughness maybe 0.1, 0.01, all right. And the glass, also the transmission, this could be like 0.7, just a little bit dimmer, not so transparent. And yeah, let's see how it looks like when we apply these. So and I will not assign these materials here in assign geometry. I will use this material linker. Now we have all these materials listed on the left side, and all the geometries are on the right side, so we can easily access them like that in a visual way. So we have to take this, for example, backplate, drag this in, and we take backplate from here, drag this in here, and now we have applied that material to that one part. But we want to apply this material to all of these backplate elements together. So we can just click on this name and just add asterisks here, and picks up all the other meshes that have the same name. There's one thing, I don't know why we can select text here, but we don't see the cursor. Otherwise it feels strange a little bit. Accept. Now let's say we want to apply the glass, applied to support clamp, and also to the support shafts. All right. Ground will be applied to the ground. The wall will be applied to wall. And rubber, we want to apply it to cables and caps. Okay, so caps. Now we will add this metal material from the catalog. So if we go here, search for brass, and just drag this in. Now we have this material here, and we will apply it to our wires, clamp wires, so, and support legs. Okay, I think the wall is currently a little bit too shiny, so let's make it less specular and add some more roughness to it. Oh, did I apply material to the neon? Looks like not. So neon, and we want to apply it to, yes, everything that is neon. So we can go here and make star only, yeah, neon star, accept. All right, now we are getting somewhere. Now let's also make a camera. Just click here with control, press down. And I want to make this camera focal length 50, actually 100 would be better. I actually previously used these lines are straight parallel to the edges. You can achieve that using the offset parameter in the camera here. So we would have 10 here. We would have to change our camera position now like that. We'll actually make a scene view here so that we see what happens. So basically our camera is looking somewhere a little bit below, but because we have this offset, the perspective shifts. Let's make it even more, 20, and again counteract that. Now we have this straight edges, and I will actually merge cameras from the side like that. If I want to add some more, it's easier that way. The lights will come in from that side. One thing that drives me a little bit crazy is that if we use a camera which has this offset, when we go out of the camera, my viewport takes those parameters from camera I was last in. Now I am basically somewhere different. Even if I correct my viewpoint, my center, my rotation is where the offset was. So really strange. Now I have to think how can I get my camera back normally. So my workaround for that is basically just making another camera, saying it's default something. Now it has just the normal settings. I center it somewhere. Now if I need to get back to my normal viewport, yeah, I can normally rotate around my subject. I don't know, maybe there is a better way to do it. So let's concentrate now on some shaders. Let's do the neon paint now. To do it, I will use the attribute which comes from geometry called neon glass. We can see that attribute if we select geometry here. We go to cable outside, and here, this is basically like a geometry spreadsheet. We see all the attributes our geometry has. And we can find here's our color, and here we have neon glass. That is actually an attribute which comes from our geometry here, and we can take a look at it. So neon glass, this is a point attribute. And I want it that way because I want to have a little bit of blur. If I want to make a really close-up shot of this neon, I can have jagged edges for the paint here. And this allows me to do it because I have this transition between 0 and 1. I can actually blur this point attribute. So let's say we want to blur the neon glass, not the position. This actually could be better because we can really say how much we want to deform that edge. So let's go back to the stage now. Material neon. We will have two standard surface materials. One will be glass and the other one will be paint. We can just add a mix, and this will be, I will actually color this dark so that I know this is the paint. So this will be something dark, and I know that the roughness should be much more pronounced, and this will definitely not be transparent. So like that, foreground, background, and let's plug it in. Of course, nothing good happens now because we have to add geometry property value. So we just write here neon glass. So this is the name of the attribute, and just plug it in the mix. And we see that it's actually now backwards. The paint is on the... Oh, is it backwards actually? Yeah, I think it is. So I will actually just take a range and invert. Will be 1 and that will be 0. It doesn't seem to work now. That, make an unlit shader and check. Yes, the attribute is coming in. And we make this 1 and this 0. Okay, kind of strange for me. This works differently than I'm used to, because like usually it's clamping below 0 and above 1, but this actually clamps this out low, and that's kind of strange to me. What you have to do is use this range without the clamp then, and then do a clamp after that. So now it's clamping it to 0 to 1. My expectation would be that this clamp functionality would be the same as this one, but it's not the same actually. All right, maybe I'm wrong. Correct me if I'm wrong. This was a little bit strange to me. So let's mix them together. And now we have a proper paint and glass separation. And the problem, of course, now is that we don't want to have this blurriness here. So we need to just do a maybe greater or equal. So we can say 0.5 here, because like a gray value is somewhere in between, right? So we can say 0, 1, or actually in this case 1, 0. Now we have again this quite harsh cut, but we can actually change where exactly it happens by adjusting this 0.5 value. I must say this rendering is a little bit slow, because when I change this value, it's a little bit hard to understand what exactly am I doing. And of course, the way maybe to counteract that and have a bit faster result, I could probably just, for example, select this and, okay, do I have my, okay, here we have our lights. So I can select my neon, my lights, and say that I want to solo them like that. And now I can concentrate more on this, and this is of course much faster than before. Actually, I also want to include the neon inside now, because otherwise this refraction is wrong. And if I press neon inside solo now, this actually overrides my previous selection. So it's also like, so I have to include it in selection and then press the solo button. Oh, okay. Maybe I just have to get used to that. But of course, we don't want to have just a straight line there. So what we can do is add the noise, and I will use the unified 3D noise. And for this, I will actually use object position, because I don't plan to move it anywhere, so that should be okay. And but you can use maybe rest position or whatever you want, or UVs. UVs have a problem that they can't have a seam somewhere. So if the tube is going, it's deforming and going up and down and left and right, then the seam sometimes can actually rotate. I find it much easier to just use procedural noises and texture it that way. So we have this noise here. And also, I would like to just select this node and debug it, like to see what it outputs now. But I can't really do it. You already saw me plugging it into this unlit shader, because that's the only way I can actually do it from my understanding. So if I increase the frequency here now, okay, we have our noise. You should be able to use the X shortcut and see the result that way, but this doesn't work also. I'm not sure what am I doing wrong, but I don't think this works. Okay, so we have our noise, and now what we want to do is use there's this burn node, burn function, and you can just burn these two values. That gradient we have with this noise. Yeah, as you can see, we have a little bit of different result there. Maybe even increase the frequency more. You can get much more detailed result there. We can use different noise here, for example, fractal. Oh, okay, so this is also clamped. If you have this parameter here, output min and output max, that's great. You don't have to make another range node. But then also, why not include the input min and max? Because then we can at least control the contrast of that noise. But if you only give me the clamp, that's not what I want. I usually just uncheck this and then make a range node and say, okay, I want -1 to 1. And this actually makes much more sense now, because what is this? What can I do with with this? Nothing. Sorry. All right. So -1 to 1. Great. Let's not clamp it. Actually, let's include in our solo also the neon back. I have to select it and only then check the solo. After that, we will take another range node. So we just clamp it down as much as we can, like that. And now we have a jagged edge there. Should be enough, I think. Now, sometimes the loading is a little bit, takes a while. It doesn't load immediately, although not that bad. Just copy this unified noise and make a height normal node. And then this we have to convert to normal map because these outputs are tangent. We plug it in our unlit shader. We can see that. Yeah, so this is our tangent normal. So if we would have a normal map texture, this basically is that. And then this converts it to object space or world space. So that is what we need to plug in the shader. You can use this scale here. I actually prefer to do it here. 0.5. Increase the frequency to 4. A little bit more detail there. Maybe also adjust the roughness. And we can use the same noise for that. Let's look at the noise now again. Use a range node, -1 to 1. And, just let's take a look what we get. We plug it in the specular roughness. Actually, if we want to really also speed up the workflow, then we can just plug this straight in. And so it doesn't have to calculate the glass. Feels a little bit better. I'll change the GOM a little bit. Maybe the minimum roughness could actually be 0.2. Maximum maybe is 0.6. Okay, 0.7. Where did my dark background go? That should be set here. Karma physical sky, and there is render light geometry. I think for this material we can also make a little bit of sheen. Not much, but maybe a little bit. 0.1, because it could have some dirt on it, some dust. Sometimes I also like to add some coat on top of this 0.1 coat. And we have another noise, but this should be maybe just a Perlin noise. Actually, its frequency could be much lower. And yeah, there could be inbuilt parameter to have some deformation for that noise, because none of these are what I actually want. But that's okay. I can actually add it myself. So make material X noise 3D. I can use another unified noise, but I don't really need that. I'll just take again the position and look at this. I think I need to multiply position. And I can choose actually here the vector 3 FA, which is one scalar. And so it's easier to multiply that way. 100, let's say. So this noise I will use actually to deform this one. So I will take these coordinates and add this. I can also say that this noise is a color noise. Now I will add this to this one, these coordinates, and plug this in. Now let's see what we get. Probably need to lower the frequency here. Let's see what happens if we have 1. Yeah, this actually looks good. We can also do it differently. So we can adjust this amplitude. So I'll just make a constant, and you have to be careful that you make a material X constant. And now I can adjust this influence of that noise. We get a much more interesting result. This looks a bit more like smudge effect, right? It looks like there is some kind of grease on this sign. We can also increase this size. That gives us a little bit more deformation, like that. It almost looks like it was wet at some point. We'll use actually this one, and this will be our coat roughness. Let's see what we get. Okay, let's plug in only the paint again, otherwise it's slower. So we get a little bit of reflection, right? So I think I will leave the paint like this. This will be normal. Let me just order this a little bit. Let's just make this more readable. You could also duplicate this position here. I just like to actually have one place for the coordinate input. And then if I need to adjust the overall scale of the texture, I can just plug here in between, like multiply, and then I can scale all the noises and all the textures and everything in one go. What do we want to do with our glass? We could also add some smudges and things like that, or we can do it a little bit later. Let's disable our solo objects. Let's actually make the background now. So it will be our wall material, and it will be a little bit more work. In this case, I will actually use the UV coordinates. It's vector 2. There is actually one thing that I need to check. Let's look at the coordinates now. We have these UV coordinates now, and they are basically procedural coordinates from the primitive. If we would have more than one polygon there, then it would be split. If we go to the SOPs, then look at the wall. So we have only one polygon, right? And we actually don't have any UV coordinates. If we would have, for example, more polygons here, now let's go back to stage. As you can see, we have for every polygon a coordinate. You can use it actually like this if you want to have, for example, these separations. And so you would have coordinates for every square, but that is not what I want to do, because I want to have some variation in this texture and some different depths. So let's make it a different way. And to do it, we need to actually go and make a UV coordinate. And we can do it here. So let's just add a UV, and we can again say that it's just a simple plane. Let's make it on the Z axis, and let's go back to stage. What we can do now, we can use a modulo, plug it there, and now multiply this coordinate. Let's say 10 by 10 or 20. Now separate vector 2. And because I want these horizontal lines, right? So I can do it like that. Then I can say sine like that. And here I can multiply this one by some number like, I don't know, 100. And we can actually make a range node here and adjust the output, for example, because sine is going from -1 to 1. So we can say -1. Now we have this gradient, which is easier to deal with. Clamp it. And what we want to do, actually, it's not about the color as much, but it's more displacement. What gives the detail is displacement. So we will concentrate on that. So this will be our lines detail, but we also want these grooves here, right? So what we can do is take this output of modulo and then subtract 0.5 to have everything go to the, like 0, go to the middle of the square. Like that. If we plug this in, yes, as you can see, now 0 is somewhere in the middle. And now we can actually clamp that. Let's say 0.1. Oh, sorry, we need to say that this is an absolute value, like that. And then if we separate this vector, get this horizontal and vertical lines, and we can actually either multiply them or just combine them by a min function, and they are combined now. And in this range, we can now say do clamp, and we get these edges. Now, because our plane, our source plane, is not square, this is a little bit squashed, although we have the same numbers everywhere. And also here, so if we say 10, this still is a little bit squashed. So I think we will just eyeball this time. Now we can actually combine this also with the min function, or lines, like that. And we have to adjust the line value so that it's not as deep displacement as our main grooves. It should be something much less, like 0.5 or even less, maybe something like that. Now, one more thing, use the lore. Okay, I will make actually this as an constant material x constant, but I will have a vector 2. This will be 10, it will be like 5, doesn't change. So I am multiplying it if this works. This doesn't work before, right? So 20? Yes. So why does not? Okay, now it works. Yeah, so this is the thing. I don't know, but you do something and there is no result. And then you have messed up all your parameters doing that. And then it starts to work and everything is wrong. So that is something that should never happen. Okay, it now works. Probably this should be like 1. Okay, so this seems kind of okay. We will actually need 2 of these range nodes because one will be for the displacement of the groove and the other one will be for the roughed up edges. So as you can see here, we have these deformations on the edges. We'll plug in here also the constant. So the values we use 0 and 0.6. And that is our in high. Now we will make another one. And let's say these values will be actually let's multiply it by A. So it will be always like 5 times bigger. If we want to have a little bit of space between these tiles, we can clamp it the in value. Now we will make a noise, but in this case, we actually can use the 2D because we are using UV coordinate. So let's take the UV, but actually let's not take the modulo one, but the original one, because then we will have overall noise over all the wall and it will not repeat on every tile. And of course, we need to increase the frequency here, or we can actually say again that we multiply it like that and we will use fractal. We will not use the clamp and we will use a bit more detail. And let's scale it even more, maybe like something like that. Okay, now I will clamp it, but not with this one, because this one doesn't do what we need. So we need to use the range, and so -1. We'll clamp it now. Let's again use this one. So separation, combining. Now we can actually again use the burn. This way we get this result, and maybe we should decrease the burning effect. Yeah, these parameters always are a little bit finky. So clamp it and then increase that a little bit. This is starting to look better. Okay, let's leave it like that. Again, clamp it down. So use a range. Yes, because we don't want the damage in the middle of the tile. We want only the edges to be affected. Now let's mix it again with this. So it looks good. I also want to offset these tiles in depth. If we look here, we can actually see the fact that these are deeper and these are a little bit higher. And also this damage, it doesn't always go like as deep as the groove. You can actually change this range to be not as pronounced. So the out low value could be something like 0.1 at least, or 0.2. Yeah, let's see when we will actually use the displacement, then it will be easier to understand what we want. Now, how can we get that offset for every tile? We can actually, because we multiply this by 10 and 20, we can actually say that we want to floor. If we look at this, we get these values, and here at the start, we can see the size of these, right? So you look at our modulo, the same size, but here these values are actually rounded, or we can actually use the ceiling, because then this is 1, not 0. And so there is this node which is random float. And because we have a rounded number here, we can actually input it here. And then let's look at this. So you can see we get a different value. But of course, the problem is that this is now a float. And I think, let me make this, okay, so this can be either a float or integer. And we can't use vector 2 in it. So we again need to separate it, and we can input it here. So we get these vertical, and we can also get the horizontal ones, right? But we can multiply this together. And so we get one float value from these two and input that in this random. And yeah, this gives us this randomness, random grid. So I think there is also noise, which is this cell noise, 3D or 2D. And if we give it coordinate here, all right, we need to also multiply it This is also another way. Actually, I previously used this randomness, but I don't know why I didn't use this one, because this definitely works. The size is also correct. I will actually use the randomness for now because I used it before and I know it works as I need. Also, we have this seed here, which is nice. You can get different results. All right, so let's leave it like that. And what we need to do is, again, combine this. In this case, I will not do it after we add those lines, before that here, right? So I will multiply everything with that output there, like that. Okay, so this is not actually what we want. We want to, yes, because we did the offset, actually add 0.5 to this. Why is that? Okay, add 0.5. 0.5. Yeah, it probably makes sense. And of course, the range for this randomness is now not really great, because I don't want the effect to be so pronounced. I want to have a little bit. So I will increase this to like 0.9. And I will actually not combine these lines with the minimum function, but I will subtract. So if we make this a little bit more pronounced, 0.5, like that. But of course, then this needs to be much more smaller value. So basically, are saying how deep are these grooves. So it should be like something like 0 and 0.1. Okay, and then after that, using the damage, right? So let's plug this into the displacement. So here we have, actually, let's also use the shader, right shader, not the unlit one, and use the displacement. Yeah, so this is of course a lot too deep. So 0.01 maybe. Let's look at from the side. Okay, so from the side we can actually see what is happening, but the dicing is now like, because we only have one big polygon, and then Karma is actually dicing this geometry depending on the viewpoint. So what we can do now is go here and restart render, and this will restart it and dice the geometry as needed. So I think this is actually a little bit maybe too much, even be 0.005. And also one thing I don't like now is that this displacement is actually, so if you imagine that our plane is here where it's the 0 value, right? And then everything that is gray or white comes forward. That means that if our geometry is on the wall will actually intersect with the geometry. So, for example, that's important here because, as we can see, the legs are now actually completely not visible at all. So what we must do to counteract that, it's actually quite easy. We just say that we want to subtract. Yeah, we can actually not use this value at all for the displacement because we don't want to do it afterwards. We want to do it before. So let's say we multiply, because here we have 0 to 1 values, and then this basically multiplies those values. So, okay, let's say we take this value, let's multiply everything, let's plug this in. Now let's make this 1. Okay, so we should get the same result basically. Let's restart the render. Yeah, so this is the same result. But now, because we know that the maximum value here is 0.005, we can subtract that value and make the constant like that. So 0, have to write it again, 0.005. Okay, so we want to take this and subtract the same value from there. Now, this is what we want, because now our 0 is actually on the front of the wall, on the front of the tiles, not inside the groove. So this is a great way to control the depth of our displacement. Yeah, and all our neon legs are also now on the surface and not somewhere inside it. Okay, so let's also add some color to this wall material. So we basically want to use almost the same thing. So let's see what we have. Why is it not showing? Okay, so let's take it from there. Well, let's see what happens if we just plug this in our base color. All right, is this clamped? Because we definitely don't want to have any brighter than one colors there. Clamp. All right, I think we will use this for a mix. So let's mix. So this will be color. So this color, we'll have like something grayish like that. We could actually multiply it also, not mix it, but leave it like that. Maybe we want to have a little bit more specular reflection, not so rough. It's hard to say it at the moment. It's probably a good idea to maybe frame some of these nodes so that we know what's where. We also can make some lights just to see, for example, what we get. We can look from the camera, and I will, for the moment, just disable the skylight. And I think we could merge these cameras before here, and then have them merged as one. And we will do the same thing with lights. So this will come in here. I'm not sure if we will actually use it at all. And then I have to add the area light here. And now I can say I want a diffuse light here. Will it work now? Yes. So, and it will adjust the light so that I get that diffuse or specular in that place. As you can see, the light changes its position. Yeah, this is actually what I wanted. I wanted to rotate this so that we have it from the side. So this lets us have these highlights on the neon. Maybe let's make it a little bit higher, not so much. Yeah, so now we actually see that this wall is quite reflective. We probably want to have a little bit less reflections. It could be even one, but then maybe it's rough. And then let's make another light, copy this, and make a specular highlight on there. And that should give us a light, which, yeah, it's actually quite hard to really get it where I want, especially because, you know, in this case, if it's a character or something bigger, then it's easier to do it. But in this case, shape is so small that it's hard to get the right place. I will just put it where I want. Also, I don't want to see this and something like that. And of course, I need a lot more intense light here. Let's increase the intensity. You can do it by changing the intensity or this exposure. Okay, so this is starting to look much better. We also understand much better now what happens with displacement in the background. Let's disable that light. I want this light to be more directional so that I don't have it there. So, and we can shape it with these parameters here, spotlight. Okay, so we can actually make the spotlight a little bit smaller maybe also, so that we can get harsher shadows. And maybe we actually want the shape to be not rectangle, but a disk. So that will give us only one parameter here, make it maybe smaller, 0.3, 0.2. And we actually can use this normalized power here. It means that even if we scale this radius up or down, the intensity should be about the same, which is useful. Something like that would work. There are also these barn doors. So in this case, I actually want to maybe cut off the top barn door. Yeah, as you can see, we can shape it like that. Because I want this light to influence more this side of the image, not so much that one. I want that one to be illuminated by the neon and a little bit of highlight from the other light. Maybe even cut this light off from the bottom like that. This looks interesting. But actually, let's keep it without the cutoff there. Now, let's enable the other light again. Okay, rotate it a little bit like that. I think we want to have it from the side, but we want it to be a little bit farther away. And it actually says Ctrl plus left button controls that. Yes, and it does. So let's make it farther away. And I also want to increase its strength and also shape it spotlight angle much less. That. Yeah, and I like this because now we get a nice spotlight on the sides of the neon. And also we get light on the edges of the background, which really makes the detail more pronounced. It looks good. We can adjust the angle a little bit, get the highlights exactly where we want. Yes, I think this actually looks quite good. Maybe a little bit less, like 5, 8. Okay, let's see it without the gizmo. Yes, I think this already looks much, much better, and we are getting somewhere now. I think I would like to make this light a little bit different color, a little bit warmer. This one. Let's enable the color temperature and maybe make it something a little bit more yellow. Yeah, so it's a little bit warmer like that. And the other one, the opposite. Make it choose some color. Okay, that's actually easier to control. Something like cyan. The backplate currently is actually not the right color. Go to the geometry here. I think we had a color there. Copy attribute from there, and we will copy it to everything that is backplate. We probably should promote it from primitive to point. And also I see that our side here is not actually facing the right direction. So let's put down the reverse and choose the backplate side group. Now if we go back to the stage, backplate, now we can actually not use this color here, but say that we want to have a geometry color, and let's input it in the base color here. And now we get the color from our geometry. Now let's add a little bit of noise, add a unified noise 3D. And let's multiply this color with this noise. You can increase the frequency here, change the frequency for every axis separately. One on the y-axis, drop down the range node, and let's clamp it. Let's change the gamma. We can make another one and multiply it again. And this one will be a fractal. Let's again change the range, -1. Let's clamp it just to add some feel of dirt. We can also use this noise to have a little bit of different roughness. But for that, let's leave this at 0 and then add another range so that we can control these separately. So this will be our color and this will be our roughness. And we want the roughness to be 0.5 and 0.2 maybe. Plug it in. Regular roughness should give us different result. I'll just order the nodes a little bit better. Copy this node here for the roughness. And I want to add a little bit of that to the wall also. It doesn't really matter that we use a 3D noise at this moment. So specular roughness. How does it look like unlit? Like that. Yeah, it definitely brings out some detail in the dark areas. But we can also add to the color. Let's mix it. Maybe let's make this 0.7, 0.5, just to break it down a little bit so that it's not so clean. Now I will add a 2D noise again. Unified noise 2D. And here I will also use the UV coordinates. Let's look at the noise and increase the frequency on x-axis. Let's check what happens if we choose fractal, for example. Of course, much more contrasty than the range. Now we actually want to have just these black lines. Let's multiply the specular with this, like that. Let's plug it in. Specular roughness. Let's see what we get now. Of course, we want to clamp this. Means that we will now have some more specularity on those lines, like that. Yeah. So those are maybe our running water places or something like that. We can also add tile random to our coordinates and offset these lines so that it mimics how water sometimes behaves on tiles. So let's add to x-axis add. Okay, let's use another random and combine it in vector 2. Let's plug it in x-axis. Now plug it in for add. We have this offset. And we can control here how much we want to offset these lines. Maybe a little bit, like 0.1 or even less, 0.005. Yeah, like that. And we can actually add another noise. Let's see where we have this one. Okay, so here is our other noise. And we can add it also to the same offset. I think we will take this out of the frame so that it's easier to organize. So add, and of course it's too much at the moment, so let's multiply it by 0.001. And now let's increase it a little bit. Yeah, so this looks already a little bit like some water damage or something like that. And it should be glossy now. Probably should add that to color. So 0.1. And where is our color input? Here. Let's multiply this with our lines. Of course, now it's too much. Add another range. We will have a lots of range nodes and increase the minimum rate. Yeah, this definitely adds some life to this environment. We could probably add some more noise to have even more variation where these stripes are or are not. But we can also just change this noise here, maybe offset it, and that way control how many stripes and where do we have them. What if we have even more frequency here? Yeah, then we have a lot of smaller drips on the wall. Maybe like 70 should be good. They want it to be even less visible, I think. Let's make it 0.9. Yeah, I will just frame these nodes to understand what they do. Water streams. Now this should be all right. Now I want to also change the material for these edges of backplate, like my brass material, geometry, neon backplate side, and also backplate edge. I can say backplate edge and then star, both edges. Now I would like to adjust the brass material, but of course I can't do it now because it's not a material from my material library. It's a material from the catalog. So to edit material like that, I have to place edit material properties node, say that I want to edit material brass, and click create parameters. And now we can change the roughness, for example. Let's see what happens. Yeah, I think this is a bit better, but I would like to add some bump or deformation to these edges also. But I can't do it in these parameters. So I would have to use edit material network. I can again say that I want to change material brass. Now click load, and now here inside I have my material brass, and here is the material network recreated. Let's add unified noise 3D, and I plug it in base color, and let's increase the frequency to like 100 and only increase the frequency on Z. Now we have these stripes here, and I think I would like to return the color how it was and only change the specular roughness. Let's look from our camera. Let's zoom in. Could be all right, just to have some detail there. Now I can delete this edit material properties because we are using only this material network editor. But I also want to mention that actually this is not a really reliable way to do it, because most of the time, even if the network is rebuilt, some parameters are not working. Even if you plug it in some other socket here, it's like almost like a random chance, will it work or not? In this case it did, so that's nice. If you have some suggestions how it should be done, then of course correct me in comments. Now I edited the material for this backplate edge, but I had it applied to support legs and wires also, but I actually want a different material there, and I want to make it a little bit more dirty with some noise. So I will just make a new one. So let's make Karma material. I'll call this metal supports. Let's go inside. I will just change the color for a little bit and go to material linker and assign it to our geometry. Okay, let's select material supports, assign it to clamp wire and support leg. And I previously had applied it to metal brass. So I will remove those assignments here, except I still want it to have tint and metalness, like 0.9 maybe. I will again use unified 3D noise. Let's make an unlit shader and check what we have. Let's increase the frequency. At the moment, we have a problem because all these are instances. The noise is applied identically to all of them. So in this case, because I'm actually not moving them around and this will be a static image, I will use a world position for this noise because that will allow us to have variation. I will also change it to fractal and I will plug it in the metalness. Let's see what we have. So we definitely need to adjust this noise a little bit. So let's not clamp it and add the range. So we have -1 to 0.2 and a little bit of metalness peeking through the dirt. Let's look at this same material in other places. Maybe we can lower the color tint a little bit. And I also want to color the specular. So I will actually promote this base color as a parameter. Now I can plug it in specular color also. And I don't think we even need any normals or bump. No. Now let's concentrate on our caps. I will solo them. I will actually duplicate this rubber material. And this will be rubber caps. And again, assign it rubber caps to caps. And before we add the assignment to rubber, so we can remove that. And now let's edit the material. I want it to be rough. So let's increase roughness, maybe less specularity, increase the diffuse roughness even a bit. I want to add a little bit of coat, even less, like 0.1, and a little bit glossier, some sheen. And this could also be with subsurface because this could be some silicone material or semi-transparent material. It's not always just rubber. Let's add subsurface and decrease the scale even less, something like that. Let's make this even darker. Subsurface could be 0.1 and specularity also less. Let's add some bluish tint to the subsurface scattering just to have some color variation. We can again add some noise to roughness maybe, but I don't think that will be as visible. So let's leave it like it is. Let's look again at the rubber material, increase maybe a little bit the roughness, and it's already a very dark material. So let's leave it like that. Let's disable our solo. Look from the camera. I think this is a great time to add Karma render settings. We can say we'll use XPU. The final render will be 4K, but at this point I will need just HD. The camera seems to be the right one. Now we are rendering with these Karma render settings here in the viewport. Sometimes if the rendering is too slow still, we can change this resolution from full to half and either use the viewport size, the render settings from here, or even input our own resolution. We use render settings prim at full resolution. And I think this is a good time to add mesh edit because this will allow us to subdivide geometry at render time. So let's add Neon Karma XPU to primitive and change subdivision scheme to Catmull Clark. Now let's check if the subdivision works. And it looks like it doesn't. We can add here flash and 2 stars, and this will include all the geometry inside this Neon Karma XPU object. Now all our cubes and everything will be subdivided super smooth. But we have this one problem. Our backplate's edge is also subdivided. So we can actually select all these 3 together. Just Control C. Now put this symbol here and add an asterisk there. Yeah, and now we excluded all these 3 geometries from our subdivision. Everything else still should be subdivided correctly. Let's look from the camera again. All materials have been assigned. What's left is we have to add the gas glow. So let's switch to build layout again, and we will take the 4th output of all three nodes, merge them together, and here we have all the curves. Let's blast away what we don't need and leave only the neon. Now we can convert this to a VDB volume by VDB from particles. These curves actually have a p-scale. You can see what size is that, and then we know what the voxel size approximately should be. Maybe even smaller. Yes, now we get something, maybe 0.02, and we need to resample this these curves to really fine resolution, 0.005 maybe even more, 2. This looks good. And the diameter of these curves now is exactly the same as our tubes. So we want to make them a little bit smaller so that the gas is not intersecting with the glass. Let's put down a wrangle and scale the float attribute p-scale times 0.4. 0.4 here, because we have to remember that we also have the inside of the surface. So it actually should be even smaller than that. Now we can see approximately what is the size. And of course, we don't want a surface, we want a density. It's hard to see it now. The other objects, put down volume visualization and increase the density to 100. Now we can see it. We will want to also include a curve U attribute, and in the attribute wrangle, we'll adjust this attribute to the length of lines, because curve U attribute starts from 0 to 1, from the line start to the end. So they are stretched differently. We'll use this attribute as a U coordinate for noise in Karma. So what we can do is get the intrinsic attribute from primitives. So measured perimeter, let's get it by float perimeter is primintrinsic, 0 measured perimeter at primnum. And now let's multiply our curve U by perimeter, and this will make the values more uniform. We could output this to another object, but I will actually just merge it in with everything else. And also, when making this VDB from particles, I want to now include this curve U attribute here, point attributes, view. I will leave the names as they are. Now we can actually go back to Solaris and check if we have our volume. Now, yes, it's here. I don't really care about its name. Let's enable Karma XPU. Now we have to make a material for this volume. So Karma material builder. Let's call this material gas, delete everything here and add Karma volume. Now we can import the geometry property, and it's called density. They plug it in emission. Now we will need to multiply this, have much brighter glow. Let's say 100. Now we can apply this material, go to gas, apply it to our volume. Now we get some glow, and we can go to material library again and increase the strength, maybe 1000. And of course we want to have some color to this, so we can make a parameter. Maybe this will be color. Let's call it gas color. Let's set it to something blue and multiply it with our density attribute. Now we have this glow in blue. Maybe we should make it less saturated and more cyan. And now let's import also the other attribute we have called curve U, and let's multiply our density with our curve U. And we can see that something is happening there. Yeah, but of course this is not what we want. So we will use this curve U attribute as coordinate for noise. We can say 2D noise, and of course we don't want it in amplitude but in coordinate. So let's make this combine 2D. Let's plug it in the first bucket, then in coordinate, and let's multiply it now. Let's increase the brightness. We can see that there is some variation, but of course we need to change the frequency of noise, and for that we can again multiply this curve U. Let's say 10. Yeah, So 100 is definitely too much. I think 10 is better. And of course, we want to increase the lowest values a little bit so that we don't have completely empty tube. So range will help us again. Change the outlaw to 0.1. We don't want to change this. We want to change the range for curve view noise. You can actually do that here by changing pivot, which moves the center of our noise, but I find it easier to control with the range. And let's increase the 0 a little bit higher, maybe 0.5. And of course, if we would like to have some movement in this noise, we could actually take either a frame or time node and add this to our curve view. Now, when we scroll through the timeline, we would see that our neon is moving. I can actually solo only our neon or gas, right? So that we see what is happening. So if I change our timeline, this noise is moving. In this time, we will not render animation. So let's disable the solo, and maybe we should still increase the brightness, or at least for the minimum values. I think 0.5 should be all right. And then overall multiplication could be even 2 or 3,000. You can promote this brightness value to a parameter also. Promote parameter. Let's call it intensity. Let's change our maximum value here so that it's easier to control it. And now I can go out of this and I can put down edit material properties, take my gas material and create parameters. And now we have both of those promoted parameters here. And if I want to change color or intensity, I don't have to go into material library anymore. I can do it just here and adjust the color also, be less saturated. Now, we of course have a problem that this gas is not properly illuminating our scene. That's because it has to go through the glass surface 2 times. It just disappears. And there are some settings that we can control. For example, let's just prune some of the geometries. So we can disable these neon tubes. Let's copy this, paste, and say that we don't need any of them. Now those are deactivated, but we want to leave the neon outside back because then we will have correct shadows from our painted parts. Yes, now we have our tubes back. Let's increase the gas intensity 2000, so that it's much brighter. And we will split our output in 2 parts. One will be our background without the tubes, and the other one will be only the tubes. And then we will combine both layers together in post. If you can suggest a different way how we could approach this, then please correct me. So in this layer, we can also set geometry render settings for our volume, and we will change this render visibility to phantom. And now it influences the reflections and makes shadows and everything. But for the primary rays, for the camera, it is not visible. So this will be our first output. And in our second output, we will have only the tubes. So let's copy this, delete the prune, and here don't need to change the render visibility, do nothing. But we want to use the holdout mode. Before we do that, I will change here what are we influencing. And in this case, it will be much easier to just choose all geometry primitives. And let's say we want to exclude from the geometry primitives everything that is neon tube. Let's select the neon tube and exclude it. So we want to exclude everything that is neon. Write an asterisk there. Now enable the holdout to matte. And this is exactly what we want. So we will have a transparent background, and also the tubes have the right refraction, because I tried to, let's say, I will this will be our two outputs. They'll also make just a preview here, and we don't want to use matte. We can say that here our neon tubes are invisible to the secondary rays. Have to wait a little bit until it recalculates. Yes, and this is the best I could come up with. So in this way we get the illumination on the wall as well as glass and bright neon tubes. But there is actually a difference between these tubes that we are rendering separately and these ones, because if we zoom in, let's say to this part, you can see that this refraction here is actually not correct. If we enable our neon tube layer, this is how it should look like. And I can see our voxel size here now, but I think when we are looking from the camera, it's far enough for us not to think about that. And let's see, maybe we don't need such a bright light here. Maybe 2000 is enough. Yeah, I actually like this a little bit better. We have a little bit more detail in our neon. Let's see how the actual output will look like. Yeah, something like that. Now there is one more thing. Sometimes you need to adjust the dicing of geometry so that you get more detail. And I think this is the case here. So for the wall, we can say again, render geometry settings. And we want to influence the wall. And here we have a tab for dicing. And we can enable, we already have true displacement, but we can adjust the dicing quality to 1. And this gives us much more crisper result for our tiles. We will leave it like that. Now we can name our outputs appropriately. And I actually like to change it here. This will be our BG, our background, and this will be our neon. I also want to take this resolution from here, copy parameter, paste relative reference. Now I can change the resolution here to 4K, and also the samples I want to increase to 256. And for the image output, I also want to use an Intel denoiser, and that should be it. If we look at our image here, there is this dirt, and I actually did it by simulating a volume in Solver and then baking the result to a texture. I wanted actually to use the trick with OP before our cop output and set it as texture in Karma, but that didn't work. So I needed to save it to texture and then use that. But let's render this as it is. Now looks like it's ready, and I will combine it in After Effects, but you can do it in wherever you want. So there it is. And this was my first version. If you have any questions or suggestions, write those in the comments section. If you found this video useful, consider subscribing, and thanks for watching. Bye.